This week we'll be hearing from Tim Hosgood, who will be telling us about open translations in mathematics.
I will indeed. Thank you so much, Jason, for that eloquent introduction. So this is going to be a recycled talk. I will shamefully admit that. And this original talk, I haven't modified the slides at all, and it was like an hour and 45-minute talk. So we're going to zip through them a lot quicker than I did when I last gave the talk. The last time I gave this talk was at the Isaac Newton Institute in Cambridge at the Modern History of Mathematics workshop program they were doing there. So it was for a very different audience. It was for an audience of historians and specifically people studying history of mathematics. I am not a historian. I am merely a mathematician. This was my opening slide, but I'm trying to sort of like I would love for real historians to start speaking at our seminar. So I'm going to take a stab at doing something that sort of bridges the gap between that. So this was a talk aimed at historians. I'll try to give it today, aimed for you guys. So I actually started the talk by talking a little bit about the Topos Institute, which I don't need to do here because we're all familiar with it. However, I will say something about the Topos Institute, which is that the fact that I was able to give this talk while working at the Topos Institute is kind of cool to me, because it's not necessarily immediately apparent how talking about how to translate mathematical documents has anything to do with the Topos mission. Something I've kind of been vibing with recently at Topos is this thing of maybe sometimes instead of trying to build one big all-encompassing language that has loads of power, it's better to let people use their domain-specific languages and build better translation tools. So I think there's kind of a synergy, as people say, going on between these two things of thinking of translation as an act that we want to sort of mirror within our approach to science and modeling, for example. So this was my thesis, and this is my thesis still. So the workshop I was speaking at, the purpose was to translate a letter, book, report, whatever you want to call it, 1892 by Brill and Noether on algebraic functions. And it's something that can be kind of phrased as a problem, right? So this is something that many mathematicians will find is there's lots of really good maths out there. And a lot of it is not written as a native English speaker. A lot of it, to me, the problem is a lot of it's not written in English. There's a lot of fantastic complex geometry in German. There's a lot of good sheaf theory and geometry in French. There's a lot that was translated into Russian during the 80s and 90s. And there's maths in languages which I don't even know what the maths is because I don't even know where to start, right? And I'll talk a little bit more about this later on. But this kind of seems like a problem at first, right? It's hard enough to collaborate anyway. When we have these sort of human barriers of language, it becomes even harder. But again, my thesis is that we don't solve this by picking a lingua franca and saying, let's write everything in English, let's translate everything to English, and then we're done. I say that actually we spin this thing upside down and find ways to make the act of translation simpler and focus on the positive outcomes that actually come from doing translation. So my claim is that the act of translation itself is thanks. So the claim is, and something someone pointed out to Karine pointed out to me during the workshop, is that actually the purpose of translation is sometimes the act of translation itself. You learn a lot about the mathematics by doing a translation. And this turns the problem into a benefit. The more we are speaking to people about things, the better things can be. This was, sorry. Okay, basically my thing was my goal is not that we stop doing these translation workshops, which is what I was speaking at, but that we have more and more of them. I thought they were very cool. Oh, sorry, yes, get rid of that. Okay, so this is what I'm going to talk about today, and I will skip over some of these a lot quicker than I will skip over others. So I'm going to talk about translation in the context of science, as opposed to just translation in general. I'm going to skip very quickly over the previous projects bit because I don't think you guys need to hear about everything I've done. And I want to focus more on 3, 4, 4 and 5 in particular are things that I would like to talk about today more than the others. So we'll skip over 2 and 3 quite quickly. So let me start by talking about translation in the context of science. So what I mean here is translation of what is often called by professional translators sort of technical translation. So it's not translation of poetry, it's translation of mathematical documents. So if you Google, this is how you start a talk, right? Is with like a powerful quote. So if you Google quotes about translation, you get this sentence, which is translation is that which transforms everything so that nothing changes. And I think many others strongly disagree with this sentence. We think it's incredibly loaded. I'm not going to say we, I'm not going to speak for them. I think this sentence is actually incredibly inaccurate and describes a sort of like fake, objectivist, mechanistic idea of what translation can be. And my argument is that even within the context of maths, which is like incredibly precise technical language, this is still not going to be the case. So one thing it's worth talking about is what scientific translation actually looks like. So originally, when I started doing translation, I was of the belief that, I'd done some translation, I'd done language courses, classes, whatever, and I'd done some translation of, essays and blah, 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 blah. And I was like, well, translating maths will be easy for a start. Like, it's mostly notation and there's no like nuance to translate, right? It's just words, they have objective meanings. Maths is I was young and naive, and now I'm just old, and that's it. But the point to make is, and I don't think I need to argue this, but I'm happy to talk about this afterwards if anyone does disagree, is that like, actually this really isn't true. It turns out that like technical translation is fiddly and presents the same problems that you would find in literary translation, just different ones are amplified by different amounts. So like what is my like evidence for this is like, there's a lot of books written about it. The rest of this talk will hopefully also point out some of the problems that we face. And also the fact that a fortnight was spent trying to translate this 1982 paper, and the group has been doing that for multiple years now. This is a lengthy progress, and there are finicky little details to worry about that in the context of maths. So this is something I will say is that in mathematics, because everything is so technical, details that are normally very, very tiny, and you might get away with mistranslating in a literary setting, now matter much more in the context of mathematics. So this is what I mean by things that are amplified by different amounts. So here are some like tiny things that you will hit if you just start translating a maths paper, some like super first obvious questions that you will kind of hit within the first 10 minutes of doing any translation. And some of them are tiny and really easy to answer. Some of them are big and really hard to answer. The key point is that all of these questions are questions that I've faced at some point, but every single one of these questions, I think, I picked them carefully, I've answered in different ways depending on what I'm translating. So none of these have a single unified answer, right? So like, should I translate notation if I'm reading a French paper and everything's called ENS for the category of sets, for ensemble? Do I translate that word to set? And like, sometimes yes, it makes sense for the reader to find things easier to read. Sometimes no, it doesn't make sense, because should you also translate like F for a sheaf? Should that become S for sheaf rather than F for faisceau, or like A for annel? Like, where do you draw the line for these kind of things, and how do you cope then with references between other works which use similar notations? A big one I found is like, especially if you read any papers that were pre-LaTeX, you'll find that quite often, so for example, in FGA 3 part 4, I think, there are 2 proposition 3.1.7s. So what do you do? Do you correct this? What is your role as translator versus editor? A big one is what happens when you find mathematical mistakes. In EGA 1, I think it's in EGA 1 towards the end, I recently received a GitHub pull request of someone informing me that one of the propositions is subtly wrong, and people now know this. Should you correct that or not? What is the purpose of your translation? Should we care about these things? Then there's things like, should I update the bibliography? One of my favorite ones is also in FGA. There's a citation, and the reference in the bibliography is just Deline secret paper. And this is like a useless thing to have in your bibliography right now. Now we know what the secret paper was. It wasn't that secret at all. It was just like a preprint in preparation. But then there's also the question of like, what if you think the paper is actually not very well explained at a certain point? How much do you spend time explaining things a little bit better, or what you think is better, or in the context of what people now know about mathematics? The key thing to point out is this one on the top right here, like, what is the tone of the prose between the dry mathematics? If you read a paper by Grothendieck and a paper by Deline, you will know which one you're reading by reading the words that happen in between. When you write a paper, you do say words, right? And at some point you try to explain things, you give introductions, you give justifications. There is literary text within there. There are a bunch of things. I'm not going to go through all of these. There's a lot of small questions that we sort of come across, and it's interesting to think about them. So this is a small little, seems like a detour, but this is something we'll come back to a lot, which is about the role of English now as a lingua franca. And like, there are lots of positive points of having English as a language of science. You know, if you look through history, we have had many languages of science. We've had Latin as a language of science. We've had Greek as a language of science. Now English is the current language of science. At some point in the past, it was German, arguably for a while. Like, we've had lots of these phases. It seems to have settled on English at the moment. But it's important to highlight some of the things that are maybe invisible to native English, especially like monolingual English speakers, which you get a lot more sense of if you go to like even universities around Europe, for example, where there is a problem that a language can face, which is when a language uses a lot of loan words for technical terms, short term, this doesn't seem bad, right? Like if in a foreign language, they don't have a word for functor and they just use the English word functor, fine, right? That's a functor, nobody cares about it. But as we believe at Topos, I would say, like mathematics eventually becomes technology, which eventually becomes society. And there are many aspects where if your language does not have the capability to talk about technical aspects, you will struggle to deal with that when it becomes societal. So for example, in Wales, how can they write in Welsh government guidelines about the use of LLMs or about the use of like data protection if they don't have the language to do so? Language which 20 years ago would have seemed incredibly technical and unnecessary for Welsh to incorporate now has become something that affects people's day-to-day lives. So these kind of effects, I'm not saying that every single mathematical word is eventually going to become life-shaping and life-changing, but it's important to not sort of shift aside the use of technical terminology in a language and say that's just for doing research mathematics. It doesn't matter for societal purposes. My point here is like, it's not actually just good to just translate everything into English and be done with it. In some sense, there should be a two-way street that we're doing. So Min-Yong Kim gave a great talk at the Topos Colloquium back in 2023, and this is actually being published in the notices of the AMS soon as a paper about who owns mathematics, a question of identity. And I'm not going to summarize his entire talk. You should definitely go and watch it or read his slides. He gave the talk much better than I ever could. But he talks a lot about this fact of how much, well, he talks a lot about a lot of very good things. A key point he draws out is how the language in which something is written shapes the historical perception of science at that time. And he has lots of good quotes. I won't focus on many of these because for time purposes, but the key one is this last one here that's in bold, which is a point he said. At some point he said, we will all be included in a book on the global history of the English written by a future historian, by which he means everybody now writing maths in English will be perceived by future historians as English, in the same way that we perceive, for example, like Pythagoras as Greek or Aristophanes as Greek because of the language they wrote in, okay? So language is important. So this is like the summary of just this part of what I wanted to get towards is that now English is the sort of lingua franca of language for science, but we shouldn't stop there. So one of the things that I'm trying to like motivate towards with some of these community translations that I'm involved in is that often translating something into English is a good first obvious step because something being available in English does make it widely available for a lot more people very immediately. But we should start viewing that as sort of like the start of projects around that specific work or that area of work to start building translations into other languages. And I guess this was more relevant for the workshop, but we should also think a lot about the sort of like choice of things that we're translating. I'm going to skip quickly through this one. This is just to say that I have translated things in the past. Like, I'm not a professional translator. I'm not a historian. I've just translated some things. And they're mostly French, and they're mostly algebraic geometry and category theory. I will talk like very briefly about a few of them, but very quickly actually. So one of the first things I started on was EGA, and I started translating this because out of spite, when I was a master's student at university, I did an introductory course to scheme theory, and I was struggling to follow it because it was a very complicated course, and the lecturer's advice was that all I had to do was go and read EGA. That was the only recommended reading he would give for the course. And for those who don't know, this is like a nearly 2,000-page collection of books written in French. And if you go and Google, back in 2015, when I did this course, if you Googled like EGA translation into English, you would find one result, which was a math overflow question of somebody asking, can somebody translate EGA into English? And 5 or 6 comments all saying like, no, because actually French is easy. And like, I only know how to say bonjour in French and I can read EGA. And actually it's just maths, it's just symbols. You don't need to read French at all to do it. I didn't agree with that. I tried to read some of the complex lemmas and the proofs, and my French was good. And it took me more brain effort to check the maths in a foreign language than it would have just done to check the maths in English. It was hard enough for me to do in English. So I started translating EGA out of spite. And now, 10 years later, we've done like some of it, but very much not all of it. So it's been me and Ryan Coletti over in America have done most of it. There's a few community contributors. Yeah, of the 1,800 pages, we've done almost 500, but that's really not very many. It's been like good, like lots of people seem to have found it useful, and the whole thing's just up on GitHub. And it's been a sort of project with a lot of ebb and flows in when, as you can see, like some things were updated 5 months ago, 2 years ago. I haven't worked on this in a while. It ebbs and flows with time. It's a project that will last a very long time. But like, why bother doing this, right? There's like modern resources on algebraic geometry, which are arguably much better written and more correct and more editable. So why bother? And there's a bunch of reasons, and I don't really want to go through all of them. I put them here because there's a lot of them. This is just the ones that came to my head. The one that maybe is the one that I think is most important to me is that like my justification, the two that really motivate me are lots of people have asked for a translation at some point. So I don't really believe these arguments of other people being like, we don't need one. If we didn't need one, people wouldn't feel like they needed one, but they do. So someone needs it somewhere. And also it's an excuse for me to read it, right? Like if I'm going to read it and sort of translate from French to mathematics in my head, then I might as well do the tiny extra effort of translating the mathematics back into English on the page. So it's fun. I enjoy it, right? Something else, I really will skip past this one. I translated a letter. This was relevant when I spoke at the workshop because they were translating a letter. There's a lot of difficult things to translate when you translate letters, but there's a lot of good maths hidden in letters. The other thing that I've actually just finished this 2 weeks ago was translating 2 of Charles Arizman's first papers on double categories. Thanks to Andre Arizman, who motivated me to do this and asked me to do it, gave me permission to republish the final things, which is very nice. And this was great because she'd already written a very lengthy errata and addenda, so we could stick all of that in. It still turns out there was a lot of terminology which I don't think has ever been translated before and hasn't ever been used outside of Charles's work. So it was kind of interesting. I think it's going to be a fun, now it's been translated, I think it's going to be a fun launching point to start some discussions on what other approaches to double category theory could kind of look like. So this was a fun paper. The project that I actually would like to talk a bit about today, because this is one that I would like to revive at some point, is this multilingual maths dictionary, which is this open source maths dictionary that I started. At some point, I was translating in French, and I was coming across words which had cognates, which meant it was hard to look up these words in a dictionary because they were used in a mathematically precise sense, which was not the same as if you literally translated them into English and then used the English word in a mathematically precise sense. It's kind of hard to go through from one to the other. So I started recording all the French things, and I just stuck it up on GitHub. And this is where I actually got a bunch of motivation was after this had been up on GitHub for like 6 months or whatever, I had a bunch of words in French, not many. There's 316 words in here at the moment, which is really not many. I got 2 emails from 2 different groups of academics in Spain/France kind of area. And they sent me 2 incredibly lengthy, incredibly technical dictionaries that they compiled in both Catalan and in Basque, which is Euskara here. And I had no idea that, I knew that I was doing my PhD in France at the time. I knew that, mathematics was still being done in French. I was not aware that people were speaking Basque, which is already a minority language, to the extent where they had words for like left exact functor or abelian category, which were not just the obvious sort of like English cognates. They actually had incredibly sophisticated technical language. There are people doing mathematics functioning in this language, and they care and want to preserve this. They're compiling dictionaries themselves. So I started like incorporating a bunch of community suggestions. Now I've had something like 50 people contribute in 16 languages. The dictionary is like quite nicely organized. Everything's linked to a Wikidata tag. So Wikidata is like run by the same foundation that runs Wikipedia. It's a really cool website with a, I think, impossible but useful target goal, which is to like every concept in the world, let's just give it a number. Like, let's just give everything a number. This is useful for mathematics, at least. I'm not going to comment on like how that fits into everything else, but it's been really useful for mathematics. So words which are often synonyms in one language, but not synonyms in another, it's useful to be able to disambiguate. So we have this nice, like, you can click on this thing and it will tell you exactly what the concept is. And at the moment, it's a pretty bad dictionary in the sense of like, for example, with French, it gives me the gender of the nouns, but it doesn't do that in some of the language. It doesn't tell you how to form irregular plurals. It's not actually useful as a working dictionary to write with. It's useful as one to like read with. So I'm going to talk a little bit about this later, about like what a future of a good dictionary might look like. Something else that was cool about the dictionary is that once you have a bunch of stuff in a computer, you can make the computer do stuff to the computer. This is a PDF, so this video won't play. That's okay. There is a video here. Pretend it's incredibly impressive. Thank you. Yeah, exactly. But it turns out when you can, so this is something I literally wrote in an afternoon in very bad JavaScript, where I can write in English like a finite scheme, and it parses it. It gives me the syntax tree. It tells me which Wikidata tag that corresponds to, and it translates it into every language it can. When it can't figure out what word it is, it returns to me the Wikidata tag and tells me it's missing that translation. But it also has some like simple, more structured parser syntax. So for example, you can type in like, let X be a scheme of finite type, and it translates it into whatever it can. But then you can switch to editing in French. It's way better with the video. I promise it was really cool. I'll show you the video afterwards, maybe. No, I'm not going to switch. I'm sharing on the wrong screen. But my key point is like, once you have, it turns out there are some very good mathematical dictionaries. Once you have them on the computer, you can do cool computer stuff to them. This one, yeah, I don't think the useful tools is going to be super relevant. This was for the purpose of like, what do we use when we do a translation? And there's a bunch of stuff we can use, right? Like, turns out if anyone ever does have the issue of trying to read a paper in a foreign language, Wikipedia is like the best bet for mathematical terminology ever. Go to the Wikipedia page for what you want, translate it into the foreign language, you'll actually find much better stuff. Wikipedia has been like, when it has the right words, it's perfect. It's not very complete, but like it's incredibly useful. Sometimes there's some small issues, but like it's basically been the best thing that we have, which is great that it exists, but not really the intended use of Wikipedia. So it would be cool if there was some more like specialized tools for this kind of thing. Like I said here, so on the left is a screenshot of what Wikidata looks like, for example. So this is the Wikidata entry Q1660, which is for the concept of an algebra over a field. So this is what I mean by it's useful for disambiguation, because in English, we just say this, we just call this an algebra. An algebra has like 20 meanings, but it might be translated into 2 different words in a target language. So it's useful to be able to go, oh, when I say algebra, I mean the Q1660 type of algebra. So the Wikidata page for this just says like vaguely what it is, and it gives you a few translations up here and describes it, and it tells you what it's also known as. Then if you scroll to the bottom, it has this useful thing, which is where it links to every Wikipedia page which cites this tag as the thing it's talking about. So this is really cool. This has way more languages than this guy does over here. This is just ones people have typed in directly to the Wikidata entry. This is from the Wikipedia corresponding pages. This is like almost super useful. It's very useful if you have some good concepts of the language, but this on its own is not useful for automated computer translation. Would anybody in the audience like to tell me why this isn't useful for automated computer translation? So for example, what do you notice about the difference between the English translation and the EO translation? So does anybody know what language EO is? I don't, to be clear. Oh, maybe it's Esperanto. Would anybody like to guess how you translate this word algebra into English? Algebra. The English one is not called algebra. It's called algebra over a field, okay? Because these languages are so cognate, that's not a big problem for us. Say I pick a language where I don't know the alphabet. Say I pick CV up here. My guess is the first word is algebra. Then it says something in brackets, right? My guess, not speaking this language, is that that thing in brackets does not appear when you actually use this word in a mathematical paper, right? This is a disambiguation on Wikipedia. Probably, looking at the other things in parentheses for more cognate languages like Dutch, my guess is that that thing means structure, like that this would translate as structure. But I don't know. I'm just guessing that, right? And then if I look down here, if you look at classical Chinese, for example, this one's fun, where the word that appears in parentheses is exactly the same as the word that isn't in parentheses. So I have no idea. Like, do you know, like, what?
That's algebra. Yeah, so that's my confused thing. So there's 3 Chinese.
Yeah.
But it seems to me they're kind of different.
Yeah. Okay. So this is another point. It's like, this is just written by people. Like, it might not even be fully correct. But this one is, because this is just like algebra, right? Like algebra and then parentheses, algebra, which is fantastic. That like shows like, I don't know, I think that's very interesting. But my key one is, so here, if I don't know any Japanese at all, for example, I have no knowledge of like, let's assume I have no knowledge at all. Maybe in Japanese, they don't use brackets. So some part of this also says structure or is some sort of disambiguation. I can't really tell. So my point is like, this is fantastic, but it's not like great if you don't speak the language good enough to know some things anyway. Anyway, yes, this is like Wikipedia has been a super cool resource. And the key point is like, there's a lot of, I mean, here, some people might look at this and go like, look, why is translation hard? It's just algebra. All of these look like the word algebra. That happens to be conveniently true for the word algebra. I will give you that. But yeah, it's kind of interesting to look through all of these. Yeah, I won't talk too much about it more. There was more talk about like how we can actually use this. Something else I spoke about is like that, again, like translation and in particular technical translation are like fields of studies. You can get a master's degree, you can get a PhD in this kind of stuff, right? And people write books about it. This is a book that's in my office right now. If anyone wants to read it afterwards, you can. It's a really cool book. It's specifically about Spanish translation, but they have a big chapter towards the end on technical translation. And they have this key point of like, one thing that makes technical translation hard is it really accentuates how much effort you've put into the pre-translation work. How much have you decided, like, all of these questions I had at the beginning, right? Of like, do I translate the terminology literally, or do I correct any mathematical things? Do I update bibliographies? Do I include errata? All of this. These are all fine detailed questions, which you can answer and you can try to answer them. The moment you have a community working on a translation together, it's really hard to get them to agree on how to answer these things. So what's helpful is if beforehand you sit down, you agree to use like Topos words, you like agree on your ontologies and you agree on your purpose and you agree like, what is the role of this translation? What was the purpose of the original work? Was it intended to be like something for everybody to read? Was it targeted to a specific audience, whatever? You sit down and you do all of these things. And yeah. there's a lot you can say about like what this sort of like pre-translation work looks like. Something that's really interesting to me is that actually this pre-translation work where you sit down and you think about the role of the article, the paper, the text, whatever, and you think about the intended audience and you think about the context in which it was written, who wrote it, what their knowledge was, what subjects you knew, whatever. This work is actually incredibly useful, not just for doing translation, but for like reading a paper as a community. Understanding the context of a thing makes it a lot easier to read sometimes. Not always. There are technical maths papers where like, it's just technical maths, you should just read it. But I would say if you wanted to like sit down and read SGA or EGA or FGA or something that's not French, having good knowledge of the context and how to approach reading it will make the journey a lot simpler. So this sort of like community pre-translation stuff is useful, even just in the context of doing reading groups on a book or something like this, I think. So I spoke a little bit about the technical things in the workshop. This is maybe people here are much more used to this sort of like open source tech stuff. So the key point is just, I was saying that like all of the translations I do, I stick them on GitHub because then people file issues. And as you can see, like some of the issues people have filed are like the kerning of mathfrak was not very good in the EGA translation. One of them is using KTech for inline rendering, but then someone else has written, this is it, the EGA 1.7.4.3. Someone pointed out that this is wrong. Actually, and I haven't actually closed this GitHub issue because I still don't know how to respond to it. Like, this proposition in EGA is wrong. And you can do pull requests, and you guys know how it works. So everything's like automatically built. Anyone makes a change to the EGA source and it releases a new PDF version. Some of my other ones are built on Forester, so it just pushes a new forest and like everything happens live, and it's all very simple and easy. This is because a lot of translation groups are still using sort of like just a big Google Drive folder or a Dropbox where they stick all their folders in, stick all their files in. So I was just pointing out that there are like more structured ways of doing this. Again, actually not super relevant. Most of the translations I do in R Markdown, because then you can turn them into web versions, which are much more friendly to e-readers and for like control effing stuff. But you get a PDF for free as well, which is quite nice. This is a super cool book, which is also on my shelf downstairs. And this represents my sort of like, one of my dream careers would be writing more of these books. So there's this book called Russian for the Mathematician. And it's a very precise, specific book, which has one goal, which is to teach you Russian for reading mathematics and nothing else. So it does not teach you how to say like, hello, my name is. It teaches you none of this. It jumps straight in. It gives you, I think from memory, it's about 20 pages about the alphabet and pronunciation, 20 to 30 pages about basic grammar, and then 200 pages of excerpts sorted by genre of mathematics with vocabulary tables afterwards. So like reading algebraic topology, reading like algebraic geometry in Russian, whatever. The reason this was, or one of the like historical reasons this book was written is during the 60s, 70s, 80s, sometime along here, the USSR spent a lot of time and effort in having researchers translate into Russian papers that were being published in other foreign languages. So there are lots of papers which originally are in German, for example, and no English translation exists, but a Russian translation exists because they recognize the importance of like keeping up to cutting edge mathematics in multiple languages. So learning Russian would have been like a really key move. It still is useful if you want to do any sort of geometry or category theory through the 70s and 80s, especially sort of early emergence of higher category theory that was nascent at the time. Speaking Russian would be super helpful. And yeah, it starts with this great like justification of why it exists, which is like the trustees of the AMS expressing its belief that a great deal of time would be saved. Mathematicians could study a textbook of Russian precisely adapted to their needs, granted to the present author 9 months of leave of absence from his duties as editor of translations. I would love to be granted 9 months leave of absence to write another book like this and just get a bunch of people to write these books. I would love to have a book that was like Chinese for the mathematician or Arabic for the mathematician. That would be so cool. I would love that. More people should write these kind of books. So let me talk a little bit now about some of the difficulties that you face in doing these sort of technical translations, which is that things can be, and this shouldn't be a surprise to anyone, right? Like technical terminology is very specific. And I've been having conversations where I've been trying to translate things from French in particular, where I can speak to a native French speaker and they cannot help me because it's a technical word in the same way that a lot of native English speakers would not be able to help you translate into a language in which they were fluent phrases like, quasi-abelian groupoid or whatever. And I've even asked mathematicians, and that's not been enough because they're not in your domain, right? And sometimes they need to be in your domain. But I've even had an issue where reading an algebraic geometry paper from the 70s, I asked my colleague, who was roughly my age, and he wasn't familiar with the terminology, even though he was a French algebraic geometer, because people start using different words at different times, right? So the big examples were trace, which threw me off for a long time, because would anyone like to guess what the French word trace translates to in English? So trace. That is one translation of it. Fantastic. And there was a sentence which confused me because Grothendieck was telling me to take the trace of two open subsets. And I was like, man, you must do something weird with like an adjacency matrix or blah, 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 blah. Turns out, no. For like 10 or 20 years, people used the word trace to mean intersection. And if you open up the French Wikipedia page for intersection, the word trace does not appear on there anywhere. So it's really like a specific terminology from a specific period of time, which frustrated me so much. This highlighted thing here was another one where I finished the entire FGA translation, like 200 pages or whatever, apart from this one thing highlighted in yellow, because when you translate it into English, it just doesn't like type check in some sense. It says like the HOM set is bijective, which just doesn't, that sets can't be bijective. You need two sets to be in bijection with one another, or you need like a function to be bijective. Turns out this was a misprint. This HOM with a capital H should have been a HOM with a little h, and it was just shorthand for homomorphisms. But I was so like thick in the weeds, I didn't see it. So I had to like reach out to Twitter for someone to help me figure it, because it turns out I knew all of the maths, I knew everything around it, but like I just couldn't translate this one sentence, and that was really frustrating. Turns out sometimes people just make little typos. This one, actually, now I can tell a different story about this, because I spoke about this at the workshop full of native German speakers, and I was hoping they would resolve my query. So this is a great paper by a big Anna on formal complex spaces, which I had to read for my research. I think it's super useful. I still haven't read it because it's in German. I don't speak German. So I can translate this first part using a combination of Wikipedia, Google Translate, a dictionary, and speaking to German people. That's just enough for me to like slowly translate it. The last sentence here, which was highlighted, I was having struggling to translate some of it. So for example, the Schnittringe, German's a lovely language where you just put two words together and it gives you a new word. Schnitt is intersection and Ringe is ring. So my guess is Schnittringe would be intersection rings. I know a reasonable amount about formal complex spaces. I've never seen the phrase intersection ring. So I don't know right now translating this, is this the introduction of a new phrase, or is this something which I've mistranslated and actually in English we call it something else entirely? And I don't understand the maths well enough to know what the word should be, because I can't read the paper because it hasn't been translated. It's like I get caught in this circle. And then the other one that comes up is Zahlenraum, which means number space, okay? Number spaces. And again, maybe that's a technical terminology that I don't know. I can't find it on Wikipedia anywhere. I can't find it anywhere by Googling it. And when I pointed this out, someone approached me after I gave the talk, and he was a native German speaker, and he said, like, he was a native German speaker translating algebraic geometry works from German into English. And he was like, yeah, I don't know. I have no idea what that means either. So like, I still don't know. And it's really frustrating to me. Maybe it is just, I don't know. Hopefully, if I keep on saying this, someone on the internet will like tell me, right? Like a good way to translate this, but I don't know. And my point is like, even native speakers who have been working in English enough that they've maybe not been familiar with some of the technical terminology in their own language now struggle to like retranslate backwards. And that's kind of, I don't know, I just find that sad in some sense, like even just on an emotional level, I don't like that. I would like that to not be the case with English as a lingua franca. But anyway, so I still haven't finished translating this, and it's really annoying because for my research, I think this paper has some really cool stuff in it, and I would love to understand it. This I'm not going to talk about too much, apart from just one thing which I know will be, this group will be sensitive to, which is, here's a fun thing when you're translating a paper about double categories, is how do you translate what they call the arrows? do you follow them literally or do you not follow them literally and use the terminology of what you're talking about? So everyone knows there's like vertical, horizontal, vertical. People disagree on this. There's taut and loose. I've heard tight and loose, arrow, pro arrow, weft and warp, which I'm still pushing as like terminology we should use. I think that's the best one. And what's really fun is if you read the Erisman paper and see which terminology he uses. I'm not going to spoil it, but like you should go read the paper and see what he uses. So there's always these questions. And another one turns up in French is like, if you look at the Wikidata page in the same way we looked at algebra over a field, if you look at what it is for sigma algebra, essentially every single language that's listed is very clearly sigma and then a word for algebra. Apart from French, which has the word tribu as well as one of the entries, which means like the translation, if you look this up in a dictionary, is that is tribe, but in the sense of a phylogenetic tree. In between like species and order and genus, there's also a thing called tribe, which is like a sub one of one of them. And for some reason, some people use this in French sometimes to say sigma algebra. And there were native French speakers in the audience. And I asked them like, oh, why do you use this one? And they were like, I don't know, like that's what I was taught at the time. Like sometimes we use this word instead. And I was like, is there a difference between the two? And they were like, so like even these things for native speakers can be like really frustrating. And it seems like such a minor detail, but when you're trying to learn from a mathematical text or explain in a mathematical text, small, tiny confusions about single words and not knowing whether the person you're speaking to is using a specific word because they have a completely different mental image from you can be really tough. It can make it really hard to like be on the same page, right? So there's just loads of fun things we get into. One of the big ones, this was another fun thing. I had a conversation with a native English speaker about the subjunctive case in English. So turns out English is a really bad language for a lot of translations. English doesn't have things that a lot of other languages do have, which means when you translate into English, things become more ambiguous. For example, when you look at like a sentence in French, there are a lot of times where in English, you might see this, right? If I write, for example, like let, can I come up with this? Like no, I can't think of how to say this in English, sorry. But sometimes it's not clear when you have an adjective, whether the adjective is modifying the noun directly after it or a bunch of the nouns that come after it, right? You need to be careful sometimes, and in English, you have to phrase things in weird ways to say like the right way around things go. So yeah, maybe, okay, an example which isn't very great English, you probably wouldn't read this, but if you said like, for example, like, let X and Y be a finite set and group. The word here is finite just for finite set, or is it for finite set and a finite group? Like that's bad writing, you just shouldn't write it like this, but I promise you there are non-contrived examples, I just can't think of any. Point is, in lots of languages, there is no ambiguity sometimes because if these words are of different gender, you can check the gender of the adjective and see where it agrees, or the plurality of the adjective, all this. So oftentimes to translate it into English, you end up with very clunky sounding sentences. And one of the big, I don't think you can call it a debate because it was between me and Ryan and one other person on GitHub we had when doing EGA, was like, how do you translate the specific French sentence, which comes up all the time, which is like any statement with, in English with like something, it is necessary and sufficient that something. So like basically like A, if and only if Y. How do you translate this into words? And all three of us had come up with different solutions, right? Like, so one of them said, in order for X to satisfy Y, it's necessary and sufficient that Z satisfy W. Someone else said for X, like most of these combinations and pairings had come up in some point. I argued that one of these is correct. And it's rare that I take such a like prescriptivist approach to grammar, but I was like, well, in English, we have the subjunctive mood. This is a subjunctive sentence. You should say, in order for X to satisfy Y, it's necessary and sufficient that Z satisfy W. Not that Z satisfies W. If it's the subjunctive, it should be that Z satisfy W. And this is useful because that clarifies which parts of the sentence are being done by which part of the thing. But it turns out lots of native English speakers, myself included up until like I was in my 20s, don't know about the subjunctive in English. And this isn't naturally how we would write it in English. So it comes across as like very stuffy and formal and doesn't feel like good English writing. The worst translation I had of this, and I do think it was worse, is someone translated it as it's necessary and sufficient for Z to satisfy W for X to satisfy Y. And that sentence like technically unravels to exactly the same thing, right? But that is so confusing to read for me as a native English speaker. Whereas like I find one of these much clearer. But this was just a slide about how English is actually a particularly surprisingly difficult language to translate into sometimes. And native English speakers, not great at English always, is what I found out. Again, myself included here. A big thing was like sort of like editorial consistency when working in community translations. This is kind of hard, right? Like, how do you get lots of people to translate one thing together? People have very different voices. Even if you took 5 native English speakers and asked them to collaboratively write a single document in English, it would not read as if one person had written it, right? So now if you add in that everyone is translating and everyone is translating with maybe a different native language and they're translating from language B to language C when they speak languages A prime, and A prime, there's no way you're going to get editorial consistency. So how do you navigate this as a community? And the answer is basically, it's really hard. We don't know. We spent a lot of time at this workshop trying to formulate sort of like high-level style guides that would help us answer the low-level questions. But then we realized this wasn't easy to do in such a way that another group who wasn't there during us writing the style guide would read the style guide in the same way. It was really hard. And it basically boiled down to like, you have to all sit in a room together and talk about it. We translated very slowly. I think in an hour-long session, we translated about 3 German sentences. That was our like rough speed of translation. Going solo, it goes way quicker, but then it's just one person doing it. There's also an interesting thing about like, when you're doing, and this is true, right, of any sort of open source community project, is what do you count as a contribution, right? So I have like a very low bar to entry where if anyone in the like 500-page EGA translation, if somebody fixes one letter, one typo, they get listed as a contributor. Like that's enough. You can be a contributor. Your name will be on the list of contributors, whatever. I was reluctant to do this at first because I was like, that's not really fair because some people have translated 500 pages. Someone's changed a single letter. Why do they get to be on the same page? And then I was like, nah, fine, deal with it. That sounds fair to me, actually. Let's just do it. Because it really lowered the bar to entry and made people more likely to correct typos. And I was like, great, that's perfect. However, I've also had some issues of people submitting a pull request and they're like, look, I Google translated or ChatGPT translated this chapter. Here it is. And that's been really difficult because the amount of time it takes to turn a machine translation into something that is good enough that I would be happy to put it alongside human translations, that takes exactly as much time as just translating it from scratch. And I would rather do the second one because if I'm translating it from scratch, at least that's an enjoyable process for me. Fixing a machine translation, I don't find particularly enjoyable. When it's like 2 people talking about their human translations that they've both done, it's different because you can talk about why you made certain choices. There's intentionality behind it. It just feels different. That's a conversation I'm happy to have. So there have been some conflicts now of like, okay, in some sense, you plug something into ChatGPT, it will translate 99% of it well for some definition of well. Okay, as a one-off thing, maybe that's fine, but like, okay, now I want to make sure it sort of fits into the style we've been translating and we fits it into the community style guide we have. We also need to make sure, like, has it taken into account all of these minor decisions that we've been trying to say? And for example, you translate EGA, they use the word pre-scheme and scheme differently from how we use them now. Has it recognized this? By the time you check every single little thing that you want done, I would rather have just done it myself at that point. I think we've yet to hit a point where this sort of stuff can be automated. And the key point here that was made by Karine, one of the audience members, and a very good historian of mathematics, was that this is where you see that like the act of translation is an important act. When you sit down and translate a paper from French to English, say, the fact that you end up with a translation at the end is great. That's cool, but that's in some sense a byproduct. What's actually really useful is the act of translation, because When you translate from French to English, you don't really translate from French to English. You translate from French into your brain and the way you understand stuff in your brain. Then you translate that back into English. You sort of like turn it into brain language or maths language and then go back to another natural language. Then to get a good translation, you like actually try to compare directly the English to the French, and you go back and forth, blah, 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 blah. But the act of sort of internalizing something and then trying to say it again in other words, I think, not to like push a metaphor too hard or an analogy too hard, is very similar to a lot of the mathematical work we do, right? Which is where we believe that category theory is a super useful language. And a lot of the work we do is reading something, internalizing it in our sort of languages that we have, and then trying to say it again in category theory. But the key point is, again, this to really push the analogy, in the same way that I don't believe we just want to accept English as a lingua franca and do this, our aim is not to take everything that exists in mathematics, internalize it, and regurgitate it as category theory. It's to ensure that the reverse process can be done, and that the people who don't speak category theory have translations accessible to them, right? We want to be reading category theory, internalizing it, and then trying to talk back in the domain languages. I think it's maybe an analogy that is being pushed too far, but I believe it quite strongly, actually. That sort of this natural language to natural language translation is very similar to the way we think about category theory as a sort of translation of domain-specific technical languages. So let me end this talk by just talking about some future resources. So these are things that don't exist, but I would love to exist. So one thing I'd love to do is this maths dictionary. I would love to make it better. So first of all, like actually make it useful as a monolingual dictionary. If I just click the tick box to just show me French, I want it to be useful as a French dictionary. So that means it should just be better. It should talk about like grammatical cases, pluralization, blah, blah, blah. It should also have a bunch of common phrases in it. That would be useful. And a key thing is something the historians pointed out to me, which I love from them, is that a good dictionary gives you examples in use. If I give you this one French word, which was only used for like a 10-year period to mean something, I should give you a sentence and a paper in which it occurred, right? That would be useful. It'd also be useful if like it weren't just one big JSON file in a GitHub repo somewhere. And it would be good if there were a big, better community structure around it. These are a bunch of like technical issues, pardon me, to be resolved. So there's this piece of software called Weblate, which is used for translation for software. So for example, whenever you use Firefox, or this thing is, I can't remember, oh, this is for translating Django, which is a web framework, something web, I don't really know, I don't remember. But say, for example, you use Firefox or any piece of technology, you can change the language of the software. And the way that that is done is not by translating by hand every single terminology within the software, right? Like someone doesn't go through and change like new tab, new window, new file, new browser. They don't translate each of them individually. They translate the word new, blank, but they do it in such a way that if my language cares about the gender of blank or the plurality of blank, then it affects the way I translate new. You code this into how you do it. So here, for example, is a translation from English into Czech, and they're trying to translate in this software. At some point, there will be a word count, and it will either say like in English, the way you do word counts is it singular or plural. So there's either one word or 10 words, right? So in English, how do you translate word? Well, it depends if it's singular or plural. In Czech, it turns out you have 3 types of pluralities. And they even give you the little formula down here, like is n equals 1, n equals 1, 0, and there's like the ternary operator down here. So like 2 to 4 use the few plurality. So in Czech, you have 1, 2, 3, 4, or more than 4, okay? In Arabic, you have 1, 2, and more. In Polish, you have like 1, 2, 3, 4, 5 plus as well. So this thing gets translated differently. But Weblate is this fantastic piece of open source software, which sort of like allows you to do translations in this way. So this is super cool, but it's tailored for software translation. I tried to like finagle this to start using it for mathematical translation. It turns out it was much harder than I had the time to do. But it turns out software engineers already have a great way to do translation of their work and to open source it and to like community request it. Similar things could be done for mathematics. This is what I said earlier. I would love for there to be some languages for the mathematician books. I would love to do a course that was like yeah, learn Chinese, but we're not going to teach you how to say anything like I went to the cinema, but we will teach you how to like do very technical mathematics in it. I think that'd be a super cool thing. I would love to see more stuff like that. Something that I'm trying to push on at the moment, and hopefully I can publicly announce some more things about this soon, is I've been trying for a while to get a multilingual maths blog going. So the point of this is, so yeah, I've spoken to a lot of people who are excited and want to like write about mathematics, but they also want to do it in their native language. This is really tough because it's not going to get published anyway. You'll have a small readership. There are lots of issues that come with this. So a lot of us got speaking. We were like, wow, wouldn't it be cool if there was just like a blog where the whole purpose of the blog was you post in your language, and or you can like cross post. You've posted something on your blog. You just put it on this like sort of like resource of like, here's a bunch of different blogs in different languages. And then I can go on and I can go, you know what? I'd love to improve my Spanish. Let me go read some maths papers in Spanish. Like, let me go read some blog posts in Spanish written by a native Spanish speaker. Could we build like a little community to gather together this sort of like multilingual mathematics introductory papers kind of thing? So there are, it turns out, a lot of people who, well, I say a lot, more than I thought, because I'm a pessimist, a lot of people who actually find this idea kind of exciting and would like to write blog posts and would like to read blog posts and see blog posts in languages they don't really know. Something that I find really interesting about this is there's a lot of like, sort of like stereotypical knowledge that we have. For example, like I've said, we know the kind of maths that was being written in French from 1950 to 1980. We have an idea of like, there was a lot of algebraic geometry happening there, lots of sheaf theory, lots of category theory. Cool. We know that like, if you're a complex geometry, you know what was happening around the 80s and 90s and how much complex geometry was being written in German. We know like early 20th century, loads of geometry was being done in Italian. But for a start, there are lots of things like I'm a complex geometer. There's so much German complex geometry I don't know because it's only available in German. But what about all the things we don't know? Like I said, I received this dictionary contribution of people in Basque. I have no idea, like, what is happening in Basque mathematics at the moment? What are they focusing on? What mathematics is being done that people who work in that area are not aware of, right? What are these happening? The other thing that like I found for this is I've been doing Arabic classes recently, and I was like, wow, why not just go crazy? Let's buy a category theory textbook in Arabic, right? This will be a great way to like crash course start learning stuff is I'll read category theory in Arabic. I know category theory. I don't know much Arabic at all, but it will be a fun way to practice. I cannot find a single article, reference book, or anything written in Arabic about category theory, apart from the one Wikipedia page, which is really short. But is it true that there are none? Like, that seems really shocking to me. Maybe it's not shocking, but it also means like there could be an entire community of category theory happening in Arabic that I know nothing about. And as a category theorist, that makes me sad because what are they doing? And as a human, that makes me sad because that's a whole community that I could be having conversations with. So in the same way that we sort of associate languages and a decade to a field, there are so many that we just don't know. And it would be cool to sort of build up some community where we get a better sense of what's happening. Yeah, this is sort of just like community building thing would be nice. Something that's like a very low technical barrier to entry that someone should do at some point is GitHub. For people who use GitHub and Git and computers, is like, that's easy. For people who don't like computers, GitHub is pretty complicated. It would be cool if someone, by which like I should do this at some point, just made like a quick, like one-click setup for like, oh, you want to do a GitHub repo for a community translation? Click this button. These kind of things. These kind of like small technical tasks, which are like feel maybe unrewarding once you are technically capable enough to build them because they seem sort of like unnecessary to you now. I think it's important to like step back and realize that like, oh, I've reached like this technical capacity and proficiency, but therefore like things that seem easy to me now were not once easy to me. How can I make them easier to other people as well? And then this one, I mean, I'm no longer at this translation workshop. But one thing that I wanted to point out, and this is something that Priya, who used to be at Topos, was talking to me about a long time ago, and I've been thinking about it a lot, which is in so many other domains of expertise, like in so many other academic domains of expertise, but also like artistic, in lots of things, the act of writing historical commentary, or even like non-historical, but just commentary on other works, is seen as like a core key component of that domain, right? And in some sense, in math, you have like Math.net, you have like these review websites where people write reviews of papers and stuff, like they review a book, but that's not really seen as important as writing a research paper, right? So why is it that in mathematics, is it true that there is no value in mathematics in just papers that comment on or exposit other papers and contextualize them and respell out what they're saying in other words? Like, why is that not seen as important in mathematics? Maybe there is a good reason why it's not. I don't believe so. I think this is sort of a cultural thing we've done, and like there is just no legitimacy and like classical prestige around this kind of stuff. And I would kind of like there to be more. So that's why I was so excited to go to this workshop, because the moment you have a workshop hosted at a place, you're like, wow, this is a real thing that people do now. And I think that's it. That's all I have to say for now. So there's a bit of a like jump around talk. Thank you all for listening to all of it. That's it. Thank you.